Say I want to cheat, or you wanted to cheat in drifting.
Okay.
How would we do that? Hello YouTube, I'm Aaron Losey from Lone Star Drift, and this is Zach.
Yep.
Zach is from ECU Master. He's here for a couple of reasons. One, he's going to tell us about data acquisition and like professional motorsports, but primarily in professional drifting. But he's also one of our drivers in the Lone Star Drift series. He drives a 350Z.
Yep.
It's a pretty simple car. He's been driving with us for a while. He has lots of cool cars like a big JZ Mark III Supra. He has a Viper. He's got all kinds of cool stuff. He has an Exo set. He's a big car guy and everything, and he's one of the locals here in Texas that knows a lot of stuff and has a lot of information. So I'm going to give it over to him. He's going to take it away.
All right.
Go.
Yeah, so Aaron approached me and we were talking about what kind of data is being used in professional level drifting at this point. You look at local Pro-Am cars, you don't really see anybody at the local event pulling out their laptop and looking at data. You see people maybe tweaking their tune if it wasn't quite right. But at pro-level drifting, it's getting more and more on the same playing field as pro-level motorsports, meaning endurance racing, off-road racing, road racing, etc. So I've had a chance to work with a couple of teams at that level and see kind of what they're using for analysis and what they're looking at. Some teams it's as simple as making sure their temperatures are correct, and a lot of them are just looking at peak RPM to make sure their gearing changes are correct. With Formula Drift, you're not allowed to have wheel speed sensors. So a lot of these guys are having to estimate wheel speed based on their gearing, and not even estimate, but calculate based on what gear they're in, what RPM, to look at what rear wheel speed they're running to get the appropriate wheel speed for the track. So yeah, it makes it a little bit challenging since you cannot directly measure your wheel speeds, because a lot of guys would look at front versus rear wheel speed. You could use traction control at that point. I'll get into how you could get around that in a minute and actually run some traction control, but we'll actually turn over here real quick. This is just kind of a simulator of a basic engine setup in a car. So your average car, you're going to have your injectors and coils. This is a drive-by-wire throttle body, which gives you some advantages, which I can cover in a minute. Most guys are just running a cable throttle to keep it simple. Here we've got oil control valves for variable cams. Do we want to get the cat out of here since he's meowing up the
That's
storm?
great.
All right. Yeah, so that's Salem.
Hi, cat.
That's the shop cat, the greeter. He's chiming along. Yeah, so every engine is going to have injectors and coils. You will have an air temperature sensor, which measures the air density. From that, we can help calculate fueling. You need to know how dense the air is because you're calculating how much fuel it takes for the mixture that's going into the engine. You've got some other sensors here that some guys run. They're optional. You've got oil pressure, fuel pressure. These are great for fail-safes. Any pro-level team is going to have probably oil temp, oil pressure, fuel pressure. I would hope fuel temp. A lot of these cars with multiple fuel pumps, you're putting so much heat into the fuel by running a lift pump and a bunch of pressure pumps that you can actually change your fuel temperature pretty dramatically, which changes the density of the fuel, which then you need to compensate for in the tuning. We've got Egt Probes. These you don't see as much stateside. You see them a lot more in Europe. Guys look at EGTs, but that can be useful if you have one in every cylinder for tuning on the dyno. If you've got a very high effort setup, you can put one probe in each cylinder. If you have an intake manifold that has a lot of variance, or if you have injectors that have some imbalance, different engines have different needs there, and so that's good just for the tuning aspect. NOx sensors, not as much of a problem on the fuels that most pro teams are running because they're not NOx limited. Just depends on the application though. Some teams are, some teams aren't. But any car that's going to be NOx limited, you'd see some NOx sensors on it. Beyond that, you've got your basics: coolant temp, air temp. So that's the basics. So you get more advanced, we can go over here. I'll show you some of the new stuff we've come out with. This is our GPS to CAN unit. So this box, this is a GPS antenna. This uses GPS and GLONASS at 20 hertz, which is a pretty high update rate. Uses a few different types of satellites and interpolation. And interpolation just means compiling data from different sources and kind of filling in the gaps. This one also is an inertial measurement unit. It's called an IMU. What that means is it has a 3-axis accelerometer, which means just like your iPhone or your smartphone, you can move it, and there are apps you can use to show acceleration in your phone. So it's a very small sensor that tells you whether you're accelerating front to back and at what rate, side to side or up and down. That's what it means with 3 axes. It also has a 3-axis gyro, which tells you your rate of rotation, which can also measure your angle. So if you put this in a drift car, you can actually watch the car's angle versus the degree of travel. So let's say you're in a corner, you can see actually like how the car is yawed versus the path of travel. So that can be pretty useful to show you how much angle the car is actually seeing on the track. From that, you can actually get the vehicle speed. You can compare the vehicle speed to what gear you're in and what RPM, and kind of back calculate your vehicle speed, which I don't think you're allowed to do in real time per Formula Drift. I'd have to read the rules again, but you're definitely not allowed to have a drive shaft or wheel speed sensor in Formula Drift. But you can have gear position. I believe you can use GPS. There's no explicit rule stating you cannot use GPS position and speed. And then we've also added recently, this is a 16-channel thermal camera, so it uses infrared, and I believe it's a 150 or 160 degree, maybe 170 degree span. So coming out of this little sensor element, it fans out and it measures 16 points across the tire. So you can actually mount these on the car. They transmit via CAN bus to the dash. Not very useful while you're driving, but you can actually watch the thermal gradient across the tire. And if you watch here, if I put my hand in front of it, let's see, which one is it? You can actually watch I'm about the same temperature as room temp, but you can actually watch the tire temperature change as you put something in front of it, which is neat. It responds instantaneously. So that for something like vehicle setup, you could see, hey, does the car need more or less camber? You can always look at tire wear, but this you can see in real time in different parts of the track if it needs more or less camber, toe adjustments, whatever. Oh, there's Salem. What you doing, buddy?
I was trying to see if it would change
Oh,
the
so you
temperature.
would measure the cat temperature? Catalyst temperature. But these are fairly new to see them commonly in cars of this caliber. Good inertial measurement units are relatively new to the scene, probably the past 4 or 5 years. Thermal cameras, I haven't had a close enough look at a lot of cars to see who's using them and who's not, but they are readily available. And as you see the budgets increase and the marketing money increase that's being paid to teams to represent certain companies, as the competition gets stiffer, people get hungrier and hungrier for more data because you have very limited testing. A lot of these tracks have such different setup requirements that if you only get 3 or 4 practice laps with a big field, especially Pro 2, it's nuts right now with 40 plus people at every event. So the more data you can collect in fewer laps, the less setup changes you have to test, and the more time you get on track, the more competitive you are. The beauty of most of this stuff is that it's expandable. So most of it uses CAN bus. CAN bus is just like a local network. So it's like plugging in your Ethernet cable to a computer in a locally wired network. So there are 2 wires, and the signals are transmitted over those 2 wires, and anything can grab them. So we've got up here an EMU black, the IMU with GPS, this camera, this little board down here, which basically transmits all these switch and analog signals over CAN bus. This keypad, all of it transmits via CAN bus, and that way if you have 16 sensors wired to this, you don't have to wire those 16 sensors to this as well. You can just transmit the data via CAN bus. So that keeps the wiring down quite a bit in the cars. That's basically it for the data analysis. I know some teams are probably going further and hiding some sensors in different places, not illegally, but hiding them in the car, measuring various things. But from the simplest setup, you're looking at temperatures and RPM, and then you get more advanced, you'd be looking at tire temperatures, watching the vehicle dynamics via measurement, and you get as sophisticated as you want. There's still lots more stuff out there that we don't make or sell, but it's pretty handy, and I think that's a good synopsis.
There's got to be more to it than this. So, first of all, can you put a GPS jammer in your car if you were going against somebody, say like Osbo, and block his GPS signal so that he wouldn't be able to run traction control type thing down the straight if they're using some type of system to do that?
I don't know what devices would be available to block GPS or to jam it.
Yeah.
I think that if they are, they'd be very illegal.
Yeah.
Because that's something that would screw with maybe something the military was doing. Because
even if it was just a super low range thing.
I don't think that's per the FCC. It's probably very illegal.
Okay.
But you can also you can get a very long way with just knowing what gear the car is in.
Yeah.
So if you know
No, I just meant screwing up the other person.
Sure. They probably have multiple strategies if they are relying on GPS, because GPS, if you go, some of these tracks don't have good cover, or if there's a tunnel you go through, or a lot of other things can interrupt that signal, or sometimes there's a very long startup time. Like ours, you get constant power, so you don't have to restart and look for satellites every time you key on. But a lot of these systems, if you cold start them, it takes 20, 30 seconds to find all the satellites. So it would be unlikely that any of these teams is really using GPS for anything real time. They're probably using it for data, but if somebody's using a traction control strategy, you can do it based on pure physics, right? If you know effectively how much grip the car has within relative terms, and you know how much power it makes in your gear ratios, you know the torque multiplied from the engine through the gears to the tire, and you know how much power you have to limit the engine to in each gear to avoid wheel spin. So it's actually pretty easy to do. Or you can look at it, REC, you can do it as well. You can just do traction control based off of engine RPM and gear. So you basically build a plot. You say, I know this car cannot accelerate faster than this in this gear, even with perfect traction. And so if it sees wheel speed increasing, engine speed increasing above a certain rate of change in first gear or second gear, per gear, then it knows that that represents tire slip. And then you could just click that off or set it on a timer.
Okay, I have a quick question then.
Sure.
So do you run that just down the straight and you run it on a timer so that you say have 5 seconds or 10 seconds where you do have traction control, and as soon as you enter, it stops?
You could do that.
Or do you do it by GPS location? Or like, how would you implement that to try and make that work? Because basically you would only want it down the straight so you don't get left most of the time. You're probably not going to use it in drift unless you're doing some type of slip angle, or like, you only want 20% wheel speed over ground speed or whatever it is. How would you implement all that?
And that's not even using wheel speed or ground speed, right? That's just using the rate of change in each gear.
Right.
So you can even set that, say, just lock it out after second gear, because you're probably never going to get down to second gear. Most of the courses are running. It's all going to be third and fourth, whatever transmission they have. So you can lock it out per gear. You could set it up on a timer. You could have the driver manually hit a switch, or you could say as soon as the e-brake gets hit the first time, that cancels.
Oh, like an if or
correct.
thing.
You can set up logic any way you want. So there are a number of ways, even without a wheel speed sensor, to limit engine power based on modeled behavior.
Okay. I don't see any like type of sensors that you're running right here. I'm sure you can for like wings and stuff, for pressure and everything.
Sure.
Do you like have any experience with that kind of stuff?
It's just a load transducer. I think it was Apexi that sold the kit back in the day. That it basically had little sticky pads that went under the bump stops for your hatch, and it would measure how much downforce your wing was providing at speed. Right? You'd set the hatch down and lock it, and then it would measure the increase over that. So they're cheap sensors. It's the same you're going to get in a $20 shipping scale. So you can implement that pretty easily into a car and log it to see how much downforce is actually being provided.
We're probably not going to use that in drifting, but you could use some type of suspension thing. Do you have anything that like shows ride height and stuff?
And I haven't.
Is it laid out? Do you have them?
We don't have any here. It basically looks like a tiny little shock absorber, right? It's called a shock potentiometer or a linear potentiometer, and it has a small shaft inside a big one and 2 connection points. And as your suspension moves, it provides a different output. And so if you wire it up as to produce a voltage, then the ECU or the dash or the whatever logging device you're using would just look at voltage and compare that to what you've said is your wheel travel.
Okay. What would you do with that data once you know it?
Just look at your suspension setup, right? If you've got a bumpy section and you can see that the tire is, not responding to road conditions properly, and you have to log those at a pretty high frequency, usually like at least 300 or 400 hertz, probably closer to 500 to 1,000, to see what the tires are doing, and make suspension adjustments based on that to make sure that the tire is spending as much time in contact with the ground as possible, right?
So are you saying that you can actually see when the tire is not in contact with the ground, or you're simply seeing when the suspension isn't functioning because it's bottoming out or doing something it shouldn't? You know what I mean? Like what's the method of looking at that data and then figuring out what the data says?
Right. So I don't have a lot of experience with it. You can see, basically, if you know that you hit one bump, if you see 3 or 4 oscillations from a single bump, you know that your suspension's not set up properly, right? You'll see normally one bump and then a little hysteresis, meaning it goes back the other way just a little bit, but it doesn't sit there and oscillate several times after one input.
Okay.
So you're looking at your suspension tuning to make sure that you're not seeing oscillations that don't represent input from the interface between the road and the tire. Sorry, this little monkey over here.
It's entertaining.
What are you doing, buddy?
That makes you more endearing to people.
Right. You got the cat.
What else could we do?
Yeah, shock potentiometers are a great one. It's not, any kind of pressure sensor. So measuring your brake pressures for your front and rear brakes and your handbrake. So it's totally within reason to put a pressure sensor in your front lines, your rear line, and your handbrake. That way you can log and look back at the data and say, hey, I used a little bit of handbrake here, maybe I need to use a little bit more. It's just really useful data to have to look at your brake bias and say, hey, the car, I felt it push on the brakes, maybe we need to adjust the balance. You could look at the pressures, make an adjustment, go out, run them, check them again. So that would be useful data to have as well. So basically anything you can measure position, speed, pressure, temperature for almost anything on the car, and integrate that with whatever device you have in it. So yeah, measuring shock travel, you can measure, are you allowed to measure steering angle?
Why not?
I don't know. I haven't read the rule book recently, but yeah, you could put a linear...
I've never read the rule book.
Yeah, and you could put a linear potentiometer on the steering rack between, like the base of the inner tie rod and the rack and measure where your steering input is. I have seen other systems where they'll use a string potentiometer, which is literally a string, and as you turn the wheel, it wraps around the column and pulls it. So it's basically a linear potentiometer that's connected to a string, and the more times you turn it, the more it moves, and you calculate your steering position based on that. So that could be data that would be used as well. If you have steering position, brake position, accelerator, you can look at all the driver inputs.
Would this not be accurate enough to tell that on its own?
It would tell you what the car is doing, but not what input generated it.
Okay.
Like if you're sideways, you don't know, and you see the car slowing down, that could be a steering input, or that could be a brake input, or that could be a handbrake input, or some combination of the three. But without knowing the pressures, you wouldn't know which one produced which.
Do you have video inputs or anything like that, where you can log video and everything?
Sure.
With all of this, so it's all synced up?
Our dash doesn't record it directly, but there are third-party softwares that you can use to sync up data with video. Okay. So you just export, this logs to a USB stick, so you just pop the data out. I think it's called Race Capture is one of the more common ones. So if you had a GoPro in the car, you could just load it up and sync the time with that point in the video, which you can see like your lap time on the dash, or you could have some indicator on the dash and sync up the video and then overlay all your data with it.
So it wouldn't have like a timestamp or something to do it, or like some type
of... The log
file.
has a timestamp and the video would have a timestamp. So as long as you've set the clocks in both of them to be pretty reasonably accurate. Our dash does have an internal supercapacitor for the real-time clock. And so like you turn it off, it still remembers what time it is when you turn it back on.
Okay.
And there's also some cool stuff with our dash. Using GPS position, it knows what track you're at. So if you save a track layout, you can preload 10 or 15 track layouts. Just getting to the track, it'll pull up the track layout and log all your data on that track layout and measure your lap times. So it's great for like time attack or road racing guys because they don't have to sit there and like plug in and reprogram the dash every time they get there. It automatically pulls up their best lap time and does predictive lap timing, which you could even set up for drifting as well. If you say, I need to be faster in this section, you could set up the predictive lap timing per corner and say, hey, in this sector I want to gain this much time. And you've got an over-under in real time, it'll tell you if you're faster or slower than the last lap.
Okay. Say I want to cheat, or you wanted to cheat in drifting.
Okay.
How would we do that?
You don't even have to cheat to use to use something that violates the idea of the rules, right? There's always in biblical terms, it's the spirit of the law versus the letter of the law. How do we cheat within the spirit of the rules? So I was going to say, like, so far we've learned a lot of this has to do with like logging things to keep the car reliable. And then some of them are logging things to try and improve performance. Sure.
What would be like the biggest thing that a normal Pro-Am drifter could do, or like a Pro 2 guy, to increase their competitiveness with something like this?
I mean, first off, make sure they have a car that runs, right? So that's where the engine health comes in, right?
Yeah.
So if you're logging engine health on all of my cars, I try to set up as much in the background to save my butt as possible, right? If my oil temps get out of control, if my oil pressure drops too far, if my water temp is out of control, I don't want to have to watch 12 gauges and hit 12 switches when I get in the car. I want to get in the car, and if something's wrong, I want it to flash at me or cut power appropriately, right? You don't want that to happen in the middle of a race, but I want to set as many warnings as possible so I can focus just on the driving. For a Pro-Am guy, I mean, you can look at your video from in-car and see your inputs and kind of what you're doing. So I don't know how much logging would help people improve their program rather than just getting seat time. I mean, at a pretty high level, you've got two components, the driver and the car, right? You see teams that have two almost identical cars and two different drivers. They're going to want to compare the driver inputs and the car outputs, right? And see where the disconnect may be, where one driver does something better than the other. So having similar sensors on similar cars with different drivers is very, very beneficial there. But for a Pro-Am guy, I mean, the most important thing is that the car runs and that you're doing what you need to do. If you're tagging off the limiter every corner, maybe you need to re-gear the car, and you can look at your data and see where you hovered and where, or what RPM you hovered and in what corner. But for Pro-Am stuff, I mean, you've done a lot more Pro-Am than I have. What do you think?
as someone that never aligns their car or like checks air pressures or does anything and just enjoys driving, I'm probably the exact wrong person to ask this. Especially like Sai's been with me everywhere. Like we were joking, we didn't even open the hood on the JZX in Japan for how long, Sai? A week at one point? Like we literally forgot to check oil. You know, like we forgot to check everything because we just like, we kind of run stockish things and just leave them alone and just hope that everything works really well, and we only give them attention when they break. Or you know what I mean? Like we wait until something completely fails.
Right.
And then we attack the problem. It's kind of the same way with a lot of the driving. We wait until there's a problem in our driving or a problem with, you know, something, and then we go figure it out. But the problem with that is we don't have any data to do it. Like all we do is like we go look and see what's physically broken with the car or our driving or whatever we're doing.
Install a new one through the access port. We'll be good to go.
Good.
JB weld up a hole.
And it makes it difficult. It would be really interesting to see like a track overlay at certain places to see where you are on track for myself.
Sure.
Which would mean I would need an exact layout of the track to see where I'm going, which could be difficult with a system like this because it's only plotting your exact path.
No. You can plot. So you can generate a course layout either by using Google Maps to create an overlay of the ideal racing line, and then you can plot your position compared to it, or you can actually drive the center line of the track and use that data to generate a track layout, and then say, hey, I'm inside or outside here. So yeah, you can actually do quite a bit there, and you can also lay out in the log your vehicle's angle relative to position on track. And you can do that with kind of a clever little plot and say, hey, I initiated much earlier here because I see that my car is at 40 degrees of angle compared to direction of travel.
Yeah. So I was going to say, I think the biggest thing for me would be like to have an overhead drone view of the track, which could be on your thing, and then watch the car go through it.
Sure.
And that could show me where I can improve and everything as a driver more than anything. Right. But I'm not the exact person like... I barely even change air pressures in my tires. You know what I mean? Like when I drove competitively, I never even did that.
Right.
I was just like, I just drive.
Yeah, and I think the biggest thing, the biggest benefit of a standalone is setting up fail-safes to protect engines from drivers and ensure that drivers can get more seat time. I mean, a lot of what we're talking about, I mean, a shock potentiometer is great, but if you rely on it too heavily, what happens when you clean a corner off the car that's an extra $400 you have to spend on a shock pot to make sure it goes back on in the middle of comp? It's just not going to happen. So it's not even practical. Teams may do it for testing and pull it off for comp. You'll see a lot of that with people who run multiple tire temp sensors per wheel. In serious road racing, when they do car setup, they'll set up 3 or 4 across the full span of the tire, and then set up one on the brake and watch the brake temperatures as well. But it's so much money in sensors that they'll pull that off for the actual racing. They do that just to set up the car and then pull it off for the actual race event.
Interesting.
So, but yeah, I mean, a lot of with Pro-Am, the goal is again seat time. It's what you always preach, to make sure that everything's fine. You can look at tire wear on the tire and see what it needs alignment-wise. But at a pro level, when you're extremely time-limited, you've got a bunch of money tied up, and you need to make a few changes for a course, or you maybe have multiple drivers in almost identical cars, you want to know what works and what doesn't, that's where the data becomes more and more valuable. But most Pro-Am guys, it's pretty low down on the rank of importance versus them just getting in the car and doing some driving.
For myself, one of the biggest problems I would have with all this is interpreting the data. Like say I had a camera here, and I was pulling temps off the tires and doing all this stuff, depending on what air pressure the tire is at, the actual tire itself, where in the lifespan of the tire you're at, and then also the surface, whether it be a mineral wells type surface or a really good road course or a corner that has a ton of rubber already laid down, I wouldn't know the temperature parameters that I would actually even want to be at necessarily. Right. Because road racing, you're in a much more specific heat range. Some of those tires might actually even tell you the heat range that they work exactly in. Drifting is kind of a wacky thing, and I don't know where a temperature range for the tire should be until I go out and maybe I just say, I delam these tires when they hit 290 degrees or something. I need to back it off to 270 or something. It would take a bunch of time for me to even learn how to interpret that data.
Sure.
Which adds a lot of cost to things and stuff again.
Right.
Yeah.
And that's something where you might do that while you're working with a tire manufacturer, but I've seen a lot of wheels and tires mounted at Formula Drift events. I've never seen somebody with TPMS sensors, which would tell you the pressure in real time, which would be interesting data to have. Maybe somebody's tried it in testing, but it's probably not practical because then you have to reprogram what sensors are on the car every time you change tires. So in a competition environment, it doesn't make much sense. But yeah, I mean, the tire temperatures, that's a great one for road racing because, you know, a slick may have this range that works, but a lot of it's the alignment settings and saying, hey, where will we gain the most time by getting the most out of the tire? You're going to give up something in other areas at every track. You got to make a choice where the car is better and worse. So for drifting, you know, who's to say where that's important or not?
Can you think of any type of sensor, something that we haven't talked about, that you could utilize?
I mean, if you know, I'm familiar with a lot of big power stuff where you're measuring coolant pressure to see if the head gasket seals or if you have an issue there. What else? Crankcase pressure on big power cars. That's more like drag racing, big power stuff. Yeah, it's not really relevant to drifting, but
I'm always thinking about like what's the magic bullet we're not talking about, or that's super interesting, or
sure. I mean, I don't know if there is. I mean, you look at like, you know, look at Chelsea's program before he was with Vaughn.
Yeah.
And it was, you know, a home-built E36 with stock ECU, and I don't know if he had any data logging. If he did, it probably wasn't much. Now he's got a great team behind with a ton of data.
You just had somebody walk behind the car and see where the oil's coming out.
but again, like, is his driving, has the level changed very much compared to the sophistication of the car and the data available? I'm sure it's paid off in degrees, right? Having a proper team obviously is a huge benefit as far as having the crew there and having the data checked over to make sure everything's healthy, but is it a big advantage at the end of the day? I mean, if the driving talent's not there, it's just not there. I don't know how much of that translates to improving driver talent, but you can say, hey, you know, you entered a little too early here. You know, seeing where the car was and where you entered, a lot of that can be shown visually with drifting because it's such a short course, you can watch all of it. The spotter tells you a lot of that.
Yeah.
But it'd be interesting to see before and after and see how much improvement could be made with looking at it. But, you know, again, it's a huge time thing, and I think most teams don't have enough staff that they're looking for more places to spend time.
I have a question for you. Could you take this setup and change your RPM instead of, like, say a lot of teams will change gearing on tracks to make things work, but oftentimes gearing will be split between certain corners to make certain things work and everything. Could you come in here and change RPM relative to GPS location on track to change the gearing through the engine, if that makes sense, and limit someone, say, in corner 1 to 6,000 RPM, in corner 2 to 8,500, in corner 3 to 7,000 to make the car work? Does that make sense? Is that something that's possible?
I don't know if you could define the logic in our software as it is now. You can definitely set up RPM limits per gear, which may do effectively the same thing. It would depend on how you define an output from the dash to the ECU. You may be a little bit limited there, but I don't know if that would be any better than the driver just not using all the RPM.
Yeah.
Because I think most drivers, innately, they know how much they're not going to give the car excess throttle and just pin it off the limiter for the sake of pinning it off the limiter.
Yeah. I'm sitting here trying to think in real time.
Yeah.
I have bad ideas. What else?
I'm trying to think what other sensors I've seen that are wild. Oh, laser ride height. Those are interesting. I don't have any here, but again, you can compare laser ride because tires are squishy, right? So measuring shock travel does not necessarily measure how much the tire's loaded up. But if you have a laser ride height sensor plus a shock potentiometer, you know suspension travel and you know the distance from the chassis to the ground, then you can actually calculate how much force is applied to the tire by how much it's been squished. So tires are almost like a coilover, right? So it's a spring effectively with a little bit of damping, but it doesn't have its own shock absorber, right? So it's a squishy thing. So you can actually measure the load directly by how much the tire has been compressed. So laser ride height plus a shock pot would be pretty interesting data to have. But again, you have to have a high enough level team that you know what to do with that data and it provides some purpose to you.
Yeah. A lot of guys, they go get blocks of wood and put them underneath the arrow, don't they, to see where they rub and everything?
Oh, really?
Is that a way they did it?
I don't know.
I don't know. I don't do that kind of stuff. For some reason, I can't get the idea of, you remember like 1990s or 80s scramble boost buttons?
Yeah. Yes.
I need a scramble boost button on my thing.
You can still do that, yeah.
I know, it's completely pointless. I would just it was in my head. Okay, I think that's most everything.
Cool.
We'll talk about all this in a different episode, but basically, ECU Master makes so many cool individual items. He'll tell us what everything does. This looks really cool. It's like a solid state switch panel.
Yeah, it replaces 16 fuses and relays and monitors every current draw on every channel every 5 milliseconds, and it can prevent problems.
All right, we'll leave all this other stuff for another video. Thank you very much, Zach.
Thank you.
Woohoo! Let's go drift.